everybody. I'd just really like to welcome you today. My name is Peggy Waters. I'm with Glance, and I'm really, really happy to present my friend Dwayne Dormany, and he is with Matthews Paint. And today we're going to go over some hot weather tips and tricks, just things you should know, and maybe some things you didn't know, or some little tricks here and there that maybe things you've struggled with. And also, we're going to have, a little time for Q&A as well, because you may have your very own questions. And we have a chat box. It's below, it's in a toolbar, usually at the bottom of your screen. It'll show you a little box and you can type in chat there. I'll be watching that as well and helping out Dwayne. And right now, I'm just going to hand that right on over to you, Dwayne.
All right. Thank you so much, Peggy. Love doing these and love working with Glance and all you wonderful shops out there. So we want to
Thank you.
be able and a resource to help you answer any questions, and welcome and thank you for taking this time with us this afternoon or morning, depending on where you're at. I plan to keep you here until about 1:30 Eastern time. If questions go beyond that, I'm happy to stay around and keep answering, but I don't want to keep anybody tied up too much longer than we have scheduled here until for the next 30 minutes. So I think everybody can see my screen. We've got the title slide up there. We're going to talk about hot temperature. We're in May, rolling into June, and temperatures are rising. And that you do got to take some special considerations in the paint booth as temperatures go up. And it's more than just reducer selection. So let's get into it and go right through. My name is Dwayne Dormany. You can see me in the middle there on the screen, but also want to make sure you know other resources you have with Matthews Paint from our company. Chris Reamer is our director and leader, and Paul and I are the two tech reps that we teach all the training classes and travel around the country to work with our sales reps and our end user shops to provide training, new paint installations, and just help with any technical problems when we can be available. Want to make sure everybody on this webinar has our contact info. You can reach out to Paul or myself directly with any technical questions you have. Our phone numbers are here on the screen if you want to take note. And email or text or phone calls, all of those are fine. And we get back to you as soon as we can if you do reach out. So let's talk about hot weather and what goes on. So when you use Matthews Paint or any other paint that's in the sign industry that's one of the higher end, our competitors or any other paint system, most of these products, Matthews Paint especially, have mixing ratios with a catalyst and reducers in that mixing ratio. So because you've got a catalyst, that paint is curing, a chemical reaction is happening, and it's drying, which means the solvents are evaporating out of it. So when you have higher temperatures, both of those things are happening at a faster rate. The hotter the temperature is, the faster paint dries. Everybody kind of knows that already, but you got to deal with a curing effect also in there, not only just the solvent evaporation. So in your application, in your flash times between coats, your recoat window, meaning how long or how short do you wait or how long can you wait after you spray a coat of paint down, what is the proper time before you can put more paint on? All these times decrease as the temperatures rise. So a little more specifics on this. We go by, and this is a generality, but we call it the 15-degree rule. So if you look up any of our product information or any data on any Matthews Paint products, any data sheets, the sheets will always give you flash time between coats, application times, how long to wait before putting a top coat on if it's a primer, or how long do you have to wait before you can clear coat it if it's a color layer. So these times that are listed on our data sheets are all listed at what we call standard conditions, which is the third line down in that box. 70 degrees, 50% humidity, That's standard conditions, and this is how we publish all of our drying times. So in this made up product, fake product, product XYZ in the chart here, you can see that you've got a 4-hour pot life and an 8-hour dry time for this specific example of a fake product. So pot life means that once you add the catalyst into that paint, the chemical reaction starts at that moment. The good news is we give you a good long time to be able to use that product. You don't have to put the catalyst in and go right in the booth and spray it immediately. Your pot life is going to be multiple hours most of the time for the vast majority of our products. So in this example, we have a 4-hour pot life. At the end of pot life, when your pot life is done, it means the paint is starting to thicken up and it won't spray out of the gun. It won't come out and lay down on the panel correctly. But that paint wouldn't be dry yet. Dry time means it's on the surface and enough solvent has come out of it so that you could touch it, handle it, maybe put tape on top of it and do a second color or apply clear coat, that sort of thing. So in this fake product, we have a 4-hour pot life, 8-hour dry time at 70 degrees. And all the 15-degree rule is that every 15 degrees, the temperature increases. All these times are going to generally be cut in half. So your 4-hour pot life becomes 2 hours at 85 degrees, and your 4-hour pot life gets cut in half again once you go up to 100 degrees. So even though we say on paper you've got 4 hours to spray this product, if it's 100 degrees in your shop, you've only really have an hour to be able to apply it and get it out of the gun. And the dry times are going to be much, much shorter as well. So go from 8 hours to 4 hours to 2 hours. The opposite is true as temperatures get cooler, but we're not talking about that right now. We're talking about the rise in temperature. So we'll just leave it at, as temperatures go down and you go from 70 down to 55, then our pot life and our dry times are going to start to double. But temperature isn't the only thing to consider. It's what we're talking about in the presentation today, but there's other factors as well that go into drying and curing times. So temperature, you can see on the top right, the hotter it is, the faster everything happens. Time by itself is its own component. So if you spray paint, just basic kindergarten level things, the longer you let it sit, the drier it's going to be. The other two are just as important and need to be noted here. The thickness of the paint is extremely important to how well that paint is going to dry. When you spray paint on, especially Matthews paint and other catalyzed polyurethane top coats like ours, you want to aim for medium coats. If you put a real thick, heavy coat on, it's going to take a lot longer for that to dry. Or if you put a real thin, dry coat on, it's going to dry really fast. And both of those can cause their own types of problems. So you want the medium bowl of porridge. You want enough paint on there for it to be smooth and even, but not so much that it's puddling or running, and not so dry that it's rough and grainy and thin. And then the fourth thing that affects paint drying is airflow. If you spray it in a booth and you've got good air moving across the booth, it's going to pick up those solvents and carry them away faster versus just spraying in the open in a dead room with no air movement around. It's going to take longer for that solvent to evaporate out and for that paint to dry up and the chemical reaction to happen. So if any of you have been to our training classes, you've seen some of this information, but if you haven't, here's just a little snippet of it. Fundamentals, kind of the ABCs of painting, the building blocks. So we want properly prepared substrates. You want to use the right products and the right spray equipment, and you want to follow our data sheet recommendations for our instructions. The one we're going to talk about here, though, is number 5 here, choosing the appropriate reducer, catalyst, and accelerator. This are the things that are going to help you apply paint in hot temperatures, still get good speed and production out of your booth, and avoid running into problems. So let's talk about reducers. Reducer terminology, historically, we call these reducers, we name them by the temperature range that they're intended to be sprayed in. So we use words like cool temp, warm temp, and hot temp reducers. And it's a good way to categorize the reducers, because a cool temp reducer, if you just dump it out by itself onto a piece of cardboard, for example, you dump out a cool temp reducer next to a hot temp reducer, the cool temp reducer is going to evaporate faster sitting there by itself versus the hot temp reducer. What that has caused in this terminology that we've done in this industry for so long, people believe and have come to think that cool temp reducer means that I can paint quicker and I can go in the booth, apply paint, it's going to flash off, it's going to dry faster, and everything's going to go faster. But what ends up happening, especially as the size of the jobs increase and you're doing larger and larger jobs, what ends up happening is that cool temp reducer that's in that paint film is going to evaporate off the surface at the top, leaving some of the other solvents that are in the can before you ever open the can or mix it. There's solvent in that can already, and it's going to trap those solvents underneath. And the cool temp reducer evaporates away, creating a skin on top of the paint film. And then the solvent trapped underneath either has to force its way out and cause what we call solvent pop, or worst case scenario, that skin gets a little thick and it'll blow little bubbles all around and have bubbles in the paint job, which no one wants to see. So cool, warm, and hot doesn't mean fast, medium, and slow. It's the temperature ranges that they are designed to be applied into, with one main caveat. The size of the job that you're spraying matters just as much as the temperature of the reducer that you're using. I'm going to talk more about that in just a minute. But cool temp by itself works up to about 70 degrees. Warm temp between 70 and 80, and then hot temp, once you go over 85-ish, you're going to use your hot temp reducer. If you're not considering the size of the job, that's sort of how you would choose, as long as the jobs are small to medium-sized things that you're spraying. The reducer by itself does more than just evaporate after you spray. One thing that we really teach and we really promote in class, when you come to class, or if Paul or I come into your shops, is to change the way you think about reducers, because reducers don't really drive the speed of your paint jobs. They drive the application and what that paint job is going to look like. And that's what we have up here on the screen. The job of the reducer, when you put reducer in your color or in your clear coat, they're going to make that can of paint, that bucket of paint, they're going to make it sprayable, thins it down and makes it spray out of the spray gun. Is going to keep those droplets wet as they travel through the air and land on the panel. And then after the paint lands on the panel, it needs to stay wet on the surface so that the droplets level out and become smooth and uniform, give you a consistent satin finish, and not be blotchy and mottly, and give an even dry appearance to it as the solvent evaporates out. And to do that, the solvent's got to stay wet through the air and be visibly wet on the surface for somewhere between 5 and 10 minutes. So getting the right reducer chosen is super important, and the size of the job matters, because as I've got highlighted there, temperature is only one of the factors in what you do, how you're picking the reducers. So size of the job matters. The bigger the job is, the hotter the temperature you need to move in your reducer selection. The other consideration is when you're doing a big job, something that's larger, has got multiple sides, and you're moving all around the different sides, as you're spraying all the way around something big, you're creating overspray every direction as you go around those big jobs. And you want that overspray to be able to settle in and land in that paint and become uniform and not be dry, grainy overspray all over the surface. So you want to, we call that a wet edge. You want to be able to keep a wet edge all the way around while you're spraying, so that you're not putting overspray all over the job as you're spraying it. So and just to reinforce what I said earlier, a faster temperature, cooler temperature reducer does not speed up your cure time. If you want to do that, accelerators is where you go for faster times. I'll talk about that at the end. We have charts with the temperature ranges for our reducers. This is an example of our conventional reducers, which is what the vast majority of our customers use, but we also have these charts for our lower VOC products. One thing to note here, if you're a Matthews customer and you use N series or SOA, our gloss series, these are your reducers that you choose from. If you notice down at the bottom, we used to have a straight cool temp reducer called 6379, and we discontinued that over 2 years ago. It's been quite a while. We just stopped selling it. It evaporated too fast, and customers in higher temperatures and doing bigger jobs got into more trouble with that reducer than it was worth. And this presentation is exactly why we discontinued that reducer. So instead of 4, we only have 3 reducers now. 45280 is our cool to warm temp reducer. 45290 is our very warm reducer, and 6396 is our hot temp reducer. We also have a retarder, but that is for big giant jobs. If you're in Florida, Texas, Arizona, places that it's over 100 degrees consistently and you need to do giant jobs, we've got retarder 45251 to help with that. Hot temp reducer is the way to go when these temperatures get hot in the summertime. Don't be afraid of it. Don't think that it's going to slow your production time down. It is there for application purposes, and it's going to make your paint jobs look better, last longer. You won't get dry overspray. You'll have so many less problems with your paint jobs if you'll go to the hot temp reducers when you need it for the hot temperatures and the large jobs. In conventional, for N series and SOA, that number 6396. For the low VOC SV, we have 2 options. We have 6302 and 6372, depending on the VOC content you want. And our ultra low VOC green label MAP LVRS03 is the number there. These will make your application and your spray gun work so much better when the temperatures are hot. So now let's talk about speed. And as I go through this, I'm going to finish up here with the accelerator overview and description, and I'm going to leave some time at the end for questions, or if anybody wants me to go back and repeat anything, because I tend to not take breaks and just keep talking. So almost done here. We'll talk about accelerators, and then I'll leave it open for questions or to review anything that we went over. To repeat, your reducer selection, all it is controlling is the application and that initial flash of your paint job. It's all about application. If you want speed, if you need the job to be painted, it to come out of the paint booth and go to assembly and LED light installation and pack it up and ship it, and it's got to get out quickly within a day or two of being painted, you're going to get speed from using an accelerator instead of from reducer. Accelerator is where the speed comes from because it speeds up everything that happens after the job is painted. So you're not just speeding up dry time, you're also speeding up the curing process when you use an accelerator. It is driving that catalyst and that paint to cure together faster, which is going to push the solvents out quicker, give you vinyl application, wrapping and shipping, doing multiple colors. All of these things will go faster using an accelerator. We've got 3 main ones that we offer. Our standard accelerator listed on top here is 287-437. It's just called HS accelerator. It's our standard strength. You can use it every day in every job. And also you can use it if you use our base coat converter, which is another topic for another time of when you would want to use a base coat converter versus not. We've got a stronger accelerator than the standard one. We call it Turbo, 287-484 Turbo Enhancer. It is 3 times stronger than the 287-437. So that being said, you're using much less of it into each mix. And there's also the MAP LVA 117 for the ultra low VOC, but all of these accelerators can be used across the board in all of our color lines. And we have charts on both of them, on all of them, to be able to use in all of our systems, which I have an example right here. So this happens to be our chart for our conventional top coats and clears, meaning in series, SOA, 4.2, 208 gloss clear, satin clear, all of our conventional, meaning high VOC products. You can use any of these three accelerators into that color system or clear coat system. And based on the number of ounces of product that you mix, that's the blue column there of top coat or clear, we tell you how many grams of each of one of those accelerators you should put into that. I do want to note, and I do want to say, the recommendation on this chart is the maximum load. So we don't want you ever putting any more than this in, because more accelerator isn't always good. It can kick too fast and you can cause wrinkling while you're spraying the job and all kinds of other problems. So try to stick with the amounts we recommend here as your maximum load, maximum amount. And then the high temperature consideration for these is, as temperatures rise and we get over 90 degrees consistently, if it's one of these hot summer days, the numbers on this chart are our maximum recommended amount. It is absolutely just fine and not a problem. We would actually highly recommend it. Use only half of the number on this amount when it's really, really, really hot. You'll still get the benefit of the accelerator, but it won't be kicking and pushing so hard that you run out of pot life or you run out of application time while you're spraying. And a lot of people think that it's two opposite things to use hot temp reducer and an accelerator, because one is slow and the other is fast. But it is absolutely 100% A-OK and recommended to use hot temp reducer and an accelerator, because the reducer does one job: make the paint thin enough to spray, keep the paint wet during application, and to lay down smooth on the panel. And then the accelerator comes in after that, and that's where your speed comes from. So hot temp reducer plus accelerator, these things are A-OK and, quite frankly, highly recommended. So in review, reducer choice, all about application; accelerator choice, all about speed. Faster assembly, vinyl application, multiple colors, shipping. Those are the benefits you're going to get from application. Reducer choice, use that hot temp reducer and step that reducer up to a higher temperature as your jobs get larger. Those are the important bullet points I want you to remember from this time we have today. So gone to about 1:23. We got 7 minutes scheduled left. And Peggy, if there's been any questions come in, fire away.
I have not, but I know somebody was having a little bit of trouble with their audio. But if anybody does have a question, go ahead and type it in the chat box, and we're happy to read those out.
Okay.
The first question: can that chart for the accelerator amount be found online?
Yes, it can. It is found on our website, and I can pull that up right now. We've got them on our website. Let me get a new browser pulled up and move it over here. So this is a good time. If anyone has ever been to our website before, oh shoot, I got to type it right. MatthewsPaint.com. There's one important thing. You can see the website, right, Peggy?
I cannot, no.
Oh, okay. Let me, screen sharing has stopped. Share right here. Share. This is an important thing. So
There we go.
Yep. So this is what our website looks like, MatthewsPaint.com. One important thing is this gray bar looks like you can click on it across the top. You cannot. If you click on this bar, it's going to take you to PPG Refinish, to some of our automotive and commercial products. It's a bad design. I freely admit this is a horrible website. What you have to do is scroll down until the Matthews Paint menu comes up. But then once you get to here, the two main sections are resources and literature that you'll go to. And under resources, We've got guides and resources where you'll find our training manual, our substrate guide. There's all kinds of good information here. And then on literature, we have stuff on all of our products that is literature based. And under additives is where you find these accelerator charts. So accelerator mix chart by weight, so you get the grams for N or SOA. This is the chart that I just had pulled up on my presentation. This is the that's where you go find it. So matthewspaint.com, literature, additives, and there it is.
Nice. Could you go over some spray gun setup tips? That's another question we had.
Yeah, for sure. Spray gun setup is critical. First thing about spray gun setup that I like to talk about is the fittings and the fluid tip size. So fluid tip determines the size of the droplets that come out of the spray gun. I have two spray guns sitting beside me here. This is a DeVilbiss spray gun. The fluid tip is the size of the hole in the center right there. And this is an Iwata spray gun, same thing. Your fluid tip size measures the size of that hole, and it's measured in millimeters. So we want between a 1.3 or a 1.4 fluid tip on the hole here. And then most spray guns are going to have 3 knobs, but not all of them. So this gun, for example, only has 2 knobs. It has a knob here, here, and there's not a knob here or anywhere on either side. So this gun only has 2 knobs. The first knob that you want to look at goes in a straight line from the air cap straight to the back. This is called your fluid control. It's basically a restrictor for how far you can pull back the trigger. Most of the time, you're going to set your trigger wide open. You don't want any restriction on there unless you're trying to get the paint down in a little tight space. You may cut that down sometime. This knob up here controls the fan. So the paint comes out of the end of the gun and goes in a triangle, and you can open and close that triangle with this knob and change how big or small your fan is. And then this spray gun, for example, doesn't have any way to control the air pressure that comes in. So you have to put a gauge on the bottom that has a knob on it to control your air pressure, because air pressure is critical on these jobs. And it tells me, I know you can't read it on the presentation, but it tells me right here, 23 PSI is the maximum I can run this gun for it to work properly. So I need a gauge on the bottom so I know that I'm running at 23 PSI or below. So you set your air pressure at the proper air pressure, and you open your fan to about 8 or 10 inches high, and you do what's called a pattern check. So we teach everybody to get a scrap piece of cardboard or something like that, put it against a wall in the booth. Do a hang 10 with your finger and put your finger on the cardboard and put the spray gun right here on your thumb. Then move your hand away. Pull the trigger for a 1 Mississippi, and you should see a nice uniform oval shaped pattern, evenly wet top to bottom, inside out. And that's what you're looking for an even pattern. If it's not even, you got to make some adjustments in fluid, fan, or air pressure to try to even everything up. And if it's crooked or funky shaped, you may have dirty or clogged air holes up here. You can take the thing apart, clean it real good. And over time, if pieces get dropped on the ground or damaged in the shop, sometimes the air cap or the fluid tip can get little dings and get damage on them inside here. And that means you just need to buy new parts or buy a new gun. So all kinds of spray guns you can buy, from very cheap to very expensive, and benefits and to any of those that you want to choose. The cheaper guns tend to not have any service or support or parts, but it's a cheap gun. So you use it until it doesn't work anymore, and you throw it out and you get another one. So, or you could spend higher dollars and get a higher end gun, and there'll be parts and service available, and you can keep that gun maintained and clean for a long time. Hopefully that answered the question.
Nice. Thank you. Any other questions? These are really good. Goodness. Well, it doesn't look like there's any other questions at this time.
Okay, great.
I would
Well, I want to
really,
say,
oh
go
wait,
ahead.
any tips on keeping edges from becoming too tall or wet?
Uh, Clarify that. You're talking about spraying something horizontal and getting like a picture frame, a fat edge around the edge. Is that what we're talking about?
Let's see. Yes. Yes.
Okay. So yeah, this phenomenon we call picture framing. And if you're spraying a flat panel on a horizontal plane, you've got the gun tilted over like this, pointed straight down, and you're painting the panel like normal. If you put a heavy coat on, which people tend to do because on a horizontal surface, you're not worried about a run. The paint's going to stay flat and level the whole time. But instead of running, it does this weird phenomenon where the paint will go all the way. I'll use my phone as it'll go all the way to the edge of the surface and it'll rise up and leave a fat edge around the surface, just like my phone case is here, before ever falling off to the side. And this is called picture framing. So the way to not do that is gun setup first and foremost. Make sure you're using the right size fluid tip. Your gun is spraying a nice even pattern, and you spray 6 to 8 inches away. You apply medium coats, and you let each coat flash before you put the next coat on. Heavy coats, too large a fluid tip, and too much material all at the same time stacking up. That's how you get those fat edges over on the edge, and that's how you avoid them.
Yeah. So small signage seems to be more difficult.
Yeah.
Yeah. And he said, thank you for the tip.
All right. No problem.
Yeah, that's Dwayne. We are just fortunate to have you today. I really appreciate it.
Well, we
Thank you so
appreciate,
much.
Peggy, we appreciate Glance, and we appreciate everybody that uses our products. Without you, I wouldn't have a job. So I am here to support you. And we thank you all. And we're a little bit past time. So if anybody wants to drop off, that will be fine. If anybody has other questions, I can hang around for a little while longer and answer anything else that comes up.
No, thank you so much.
Thanks, everybody.
All right. Thank you.